Hello, my name is Daniel. In this video, I'm going to walk you over Qiskit Quantum Machine Learning. So here is the Qiskit website. If you go to the qiskit.org, and you can go to this page. And this is the document for the quantum machine learning. So you can click on the overview right here and then to get some idea about this software. Okay, and I'm gonna start with the getting started. Okay, so here all you have to do is install some software. Okay, and the first one is the Qiskit machine learning package right here. Okay, so you can start command line share here. I think there's one. Okay, and you can just follow the direction. By the way, you have to have the Python. Okay, so let me check the Python version. Okay, so I'm using the Python 3.9.12. okay, and so you can just pip install Qiskit and followed by the quantum machine, the machine learning. Okay, so using the square bracket. And since I already installed the Qiskit machine learning, so I will not going to install it again. Okay, so you can follow this. This is the one you need to install. Okay, to your computer. I'm using the Windows, but see, I'm using the Windows version 10. Okay, and it recommend the PyTorch. Okay, and you don't have to install the PyTorch. Okay, but you want to install PyTorch, that's fine. Okay, and you may also install the sparse package. Okay, to deal with some sparse arrays. Okay, and also it recommend the Jupyter-Lab. Okay, so for the Jupyter-Labs, you need to download the Jupyter-Lab from another website. So you go to the Jupyter-Lab. Okay, so you can go to Jupyter.org. So here's how you can pipe install or pip install Jupyter-Lab. Okay, and then also to start it, you can type Jupyter-Lab. Okay, so I'm gonna go back here and then go to the tutorial. But I'm gonna show some test code. Okay, I click on the migration guide right here and click on the Qiskit machine learning v0.5 migration guide. Okay, so I am actually now using the v0.5. okay, and the old version is the version 0.4. okay, so there are some notes right here. So basically from the 0.4 to 0.5 the software has been through a major change. Okay, so it has the new base class, base assembler, and base estimator. Okay, and also the new quantum kernel. Okay, so the previous implementation with the 0.4 consists of a single class, the quantum kernel, that do everything basically. Okay, and the new kernel, okay, it actually split it out. So this is the old one. Quantum kernel is the 0.4 implementation, and 0.5 implementation is actually quite a few stuff. Here's the QSVR and the QSVC, and both are coming from the abstract class base kernel. And also there's the fidelity quantum kernel, and along with the trainable kernel and the trainable fidelity quantum kernel. So these are the new stuff in the version 0.5, and the 0.4 is always only the quantum kernel. So I'm gonna use the new implementation. So here is some description about the new added classes. Okay, so here I'm just gonna follow this page, and with my software. Okay, and by the way, my Jupyter, I think wait, hold on, keep typing error. I'm using the Jupyter-Lab 3.5.2. Okay, in case you are using different versions of Jupyter-Lab, there might be some discrepancies. Okay, so keep this in mind. I'm using 3.5.2. Okay, so I'm gonna start a Jupyter-Lab here. Okay, and install the Jupyter kernel, and also it created a client using this Microsoft page. Okay, and here is some code already there. Okay, I'm just going to new one. Okay, so I'm gonna use the Python 3. Okay, so okay, so first I'm gonna cut and paste this piece of code. So this is doing the just using the algorithm globals implemented in the Qiskit util. So we will know if the system is ready for you to implement or write your quantum machine learning code. Okay, so I'm just gonna copy this piece of code and then pass it over to the Jupyter-Lab here. Okay, and then run it. So if you don't see any error messages, you're gonna see the number 1 right here. That means this piece of code is working. So that means that now I am able to use the Qiskit.utils algorithm globals to do something. Okay. Then the second thing I'm gonna do is I'm gonna create a data set using scikit-learn. Okay. So here I cut and paste this piece of code. Okay. And I paste it over here. So this is using the scikit-learn data set to import this matplots. Okay, and it's gonna create some data set and put the data into the features with the labels. Okay, so I'm gonna run it, and it's working. Okay, so that is our data set we already generated. And now this is the previous implementation in quantum kernel, so it should be compatible, but I'm not gonna try it. Okay, if you want to try, you can try it yourself. So I'm going to use the new implementation. Okay. So new benefit starting from here. So I'm gonna using the Qiskit algorithms, state fidelities, to import this module, the compute and compute. Okay, and then I'm gonna copy fidelity. I'm gonna copy this piece of code and need to create the fidelity. Okay, so it works. So now I have fidelity. And according to the description of fidelity we generated, okay, we'll need to give it to the fidelity quantum kernel. Okay, so I'm gonna create a new kernel using this fidelity. Okay, and I run it. Now I got some error. The error says that the ZZ feature map is not defined. Okay, so we actually need to find the ZZ feature map. Where is that? Okay, so obviously this ZZ feature map is somewhere, and we need to import it. Okay, so first you can copy this piece of copy this ZZ feature map, and then go to create a tab, go to Google search, okay, and then search Qiskit map. As I said, Qiskit says not defined. Okay, and now you can see the Qiskit map is under the Qiskit circuit library. Okay, so it's under here, so we need to import it, otherwise we won't be able to use it. So since we already installed the Qiskit, it should be somewhere in the system already. Okay, so I'm just going to import that. Okay, import that. So put it here from this package. Okay, then import. Okay, this guy. Okay, and run it. So now, yeah, we remove the errors. So now we have the feature map and the new kernel already created. Okay, then we can move on to the next one. So now we already created this one already. Now we're gonna fit an SVN classifier. SVN stands for the support vector machine. Okay, so we're gonna create supported vector machines, and then copy it over and paste here. Okay, so now we got the data, we got the fidelity, we got the kernel. Okay, and then we're gonna run it using the QSVC. So that's the quantum support vector machine classifier. Okay, and using our generated data features and labels. And then I use the score, to give you the accuracy. Okay, so I'm gonna run it. I give you the 95% accuracy. Okay, using the support vector machine in the quantum versions of support vector machines. Okay, and that is working for the support vector machine SVN. Now we're gonna try the quantum neural networks. Okay. So in the quantum neural networks, we have the sampler QNN, and that kind of replace the old circuit QNN. That's the old one. Okay, and the existing circuit QNN is now pending deprecation, as you can see that. So we are not going to use the circuit QNN. We're going to use the sampler QNN instead. Okay. Okay, so here is the quantum circuit we have. Okay, so we're gonna copy this piece of code. Wait, the quantum circuit. Okay. And this is a circuit QN, and that's the version 0.4. We will not try. So let's try to use the sampler QNN. Okay. So we start from here. So we just import the sampler right here. Okay. So we copy this guy and then paste it over and run it. Okay. Now we create an instance of sampler QNN. Okay. Okay. So it actually pastes quite a few. It passes a parity. So we need a parity defined. Okay, right here. Okay. And also the feature map. I think feature map is somewhere. Somewhere we. Oh, this is the parity we need to define. Okay. And the feature map right here. So we need to run this piece of code. Okay. So that we have the feature map. So before we can run it. So let's run this piece of code. Okay. So we have the feature map created and the parity. So now we also need to define the parity. And then the initial point. This is some just set random seed. Okay. So that we can generate the identical data every time. Okay, after we done that, then we move on to run this piece of code. From here, we're gonna run the sample the QNN. Okay. Wait, not here. Okay. So now we have the sample the QNN, and then we can now run the neural network classifier. Okay. 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 The first thing is we don't have this neural network classifier defined. So we need to import it from, if you Google search, it cannot be somewhere under the Qiskit Machine Learning algorithms. Okay, so I can copy this piece, copy this keyword, and then search this guy. Okay. Okay. Oh, I think we need to add a Qiskit. Okay. Yeah, this guy. We need to click on it, and then so it's under actually here. Qiskit Machine Learning algorithms classifiers. Okay, right here. It's under right here. So we need to neural network classifier. Okay. So it's a neural network classifier right here. Okay. So okay. Here's a neural network. Classify. This is one word. Okay. Okay, so okay, so here the module code and where's the class hierarchy? Okay. So this is neural network classifier. Okay, neural network classifier. It's under here. It's under the Qiskit machine learning algorithms. Okay. So we're gonna import that. Okay, import from Qiskit machine learning algorithms. Import neural network classifier. Okay, and run it again. Now we find the neural network classifier, but the copula is not defined. So again, we copy this guy and then find where it is. Okay. So the copula is under here. It's under Qiskit algorithms optimizer. Okay. So it's one of the optimizers. Optimizer. Optimizer. Okay. Yep. Optimizers. Qiskit algorithm optimizers. Qiskit algorithm optimizers. Okay, and then run it. Okay. So now we got, this is just a warning, okay? The sparse was renamed to this, some warning messages. Okay. Okay. Sparse output is ignored unless you leave sparse to its default value. Yeah. Okay, this is some warning message, but the output is correct, 0.6 right here. Okay. So far so good. So we have make this work. And the last thing I'm gonna do is the estimator. So estimator, it's a new implementation to replace the old version upflow QNN. Okay, so I'm gonna follow this tutorial. Okay. Okay, so building this guy. So we're gonna do this. Okay, estimator, and it circuit the input weights, estimator, and so forth. So we need to create that. So we need to run this piece of code. Okay, to do that. So let's run this piece of code. Okay, so that's first thing, and also we need to construct the feature map and sets and all other. Okay, run this piece of code, and also fix the initial point to get some result. So I'm gonna do this to set the random number seed. Okay, so once I got that, and this is the old version, the upflow QNN. I'm not gonna try it. I'm gonna try the new one, the new implementation estimator QNN. So I start from here. I'm gonna create an instance of estimator. Okay, and followed by, now we're gonna create an estimator QNN. Okay, and run it. It's working now. And lastly, I'm gonna construct a variation of quantum regressor and feed it like this. Okay, test it out. Now it does not find the regressor. Okay, so I think we need to import this as well. Okay, so regressor should be somewhere in the algorithm as well. Okay, so you go here and let's search it again. It should be Qiskit. Okay, so it should be, yeah, it's under the Qiskit machine learning algorithms there. Okay, so I'm gonna import it again. So here I'm gonna from machine learning algorithms import neural network regressor. Okay, so this is the one missing. Run it again. Now it got everything, and it give it output the 0.9789 and 0.9789. So actually higher than this one, so it's good. So far your system is actually ready to the quantum machine learning programming. Okay, so that's all I have. Have a good day. Bye.